Hi everyone. In today's video I will be going over the Q3 benchmark review. So the first 6 problems are all graphing. This will be a huge refresher on how to graph different types of curves. So first we have the sine curve. 2 things you need to remember about the sine curve. It starts at the origin. And then again, that depends on if your origin is shifted or not. And then it has an S curve to it. So let's say it starts at the actual origin. It starts there. The next point it goes up and creates a maximum. Then it comes back down to the midline, down to make a minimum, and back up to the midline. So that's the shape it creates. All right, so we have our equation here. We have to find these 5 pieces of information before we can make our graph. First is the amplitude, that is your A. A is the number there in front, so 5. And remember that means it goes up or down 5, and actually it does both. It goes up 5 and down 5. And then the period, the formula you need for that is 2 pi over b. B can be in one of 2 places. It can be in front of the outside of the parentheses that holds the x, or if we compare it to number 2, it could be actually in front of the x. We will put it in one place, not both of them. So look in both places to look for your b. So this time it's outside of the parentheses. So here it's 2 pi over 2, and that just gives us pi for the period. Your interval is your period over 4. So here the period was pi, so it's pi over 4. It's a very common interval to have. Phase shift, you set what's in parentheses equal to 0. So x equals 0, and that means we have no phase shift. So we start at 0 on the x-axis like we're supposed to. Lastly, the vertical shift is this bit at the end here, that plus 2. So, reminder, that is also where your midline is. And the vertical shift, we go up 2. I'm going to draw that midline through 2 on the y-axis. And that is actually where I will start. Yeah, I'll go ahead and do that on this problem. But I typically like to do this after I remember intervals. So, you draw that line through 2. So that is now our midline. And then we need to mark our interval numbers. So our intervals are pi over 4. So this first marking here is pi over 4. Next we have 2 pi over 4, which is pi over 2. Again, if you need to reduce, kind of take 2 steps to reduce, so you can write 2 pi over 4 down here. And then the reduced version is pi over 2. And then 3 pi over 4. And then 4 pi over 4, which is pi. Which that's our 4th number, so that should be the period pi, which it is. And then I'll go 4 to the left, but negative. So there are my intervals. And then we already graphed the vertical shift, no phase shift, so our origin just moved up 2. So that's where we start the graph. And then we could just go on and plot our points. So we start at the origin. The little circle we got there. And then we're going to go up 5 for our next point, because our next point is a maximum. Now we don't have the space here, so we have to make our y-axis taller. And I need 2 more numbers here. So we got 1, 2, 3, 4, 5, yes. So this is my max. And then back down to the midline for our next point. Then we come down 5 to make a minimum. So we go down 1, 2, 3, 4, 5. And then back up to make a maximum. And that's a complete S curve. And then we have to go 4 more to the left to get a second period out of this. Now when we go backwards, we're going to go down instead of up for our first point because we're repeating that pattern. So we go down 5, then up to our midline, and then we come up to make a maximum, and then back down to our midline. And then we could draw on the curve. Something like that. So a reminder, the rule of thumb is to graph 2 whole periods. So one way to do that, to know you have 2 periods itself, because with the phase shifts, this does get a bit confusing. Graph your first point, and then you need 8 more points on top of that. So here it looked like 4 to the right and 4 to the left. You'll see a few different variations from there on other graphs, but 9 points in total. Number 2, we have the other big type of graph, which is the cosine graph. You need to know a couple things about cosine, the cosine curve. First, it starts at the maximum, and then it has a U curve. So, if it was just plain cosine, it would start at its maximum here, then it would go down to the midline, then the minimum, back up to the midline, back up to the maximum. And so it would look like this. All right, filling in our information, the amplitude is 2. Period, we are still using 2 pi over b. And this time b, as I pointed out earlier, is in front of the x directly attached to it. So it's 2 pi over 4, which reduces to pi over 2. Interval is the period over 4. So it's pi over 2 over 4. Now if you remember your keep, change, flip rules, that's pi over 2, change division to multiplication. Now, instead of 4 over 1, that's going to be 1 over 4. So pi over 8 is the interval. And then the phase shift, we set what's in parentheses equal to 0. So this is 4x minus pi over 2 equals 0. And actually, I'll come down here to do that math. Add pi over 2 over, we have 4x equals pi over 2. And then we are dividing by 4, which is exactly what I did up here. So that's going to get us pi over 8. So our phase shift is x equals pi over 8. And then our vertical shift is, again, that bit at the end, minus 3. All right, so let's fill in our intervals first. So our intervals are in pi over 8. So we got 1 pi over 8, 2 pi over 8. Yeah, I'll be fine. I just need to be more careful in the next few. Looking ahead, see, that's going to affect my spacing later. That reduces to pi over 4. And then we have 3 pi over 8. And then 4 pi over 8, which reduces to pi over 2, which is the period. I'm at the 4th number out. I should be at the period number, which I am. And then I'm going to go backwards, but negative. All right, from here we need to graph our shifts. Phase shift is x equals pi over 8, so we're going to put a line through pi over 8 on the x-axis. And then minus 3 on the vertical shift, so a line through negative 3 on the y-axis. So where they cross, that is my new origin. It's my new starting place. And now we can graph. So this is the cosine curve. We start at a maximum. So we go to our origin and we go up and down 2 on the graph. So we're going to go up 2. That is where our first point is going to be. And then we go down to the midline for our next point. And we need to extend the graph one more time because we have to go down 2 from there. And then back up to the midline. Now it is acceptable to stop here and not get a 4th point because when I go backwards, the phase shift made it so I want to have 5 points to the left instead of 4. So that's going to make up for missing a point over here. So now I'm going to go backwards. So the cosine function does mirror itself. When you're at a max, you only have one choice but to go down. So I'm going to follow the same pattern the other way. So we go down to the midline, then we go down to make a minimum. Back up to the midline, back up to make a maximum, back down to the midline. And I just connect. Yep, and I still have my 9 points in, so I'm good on that. All right, that was 2 graphs. Now let's move on to the secant and cosecant. Now we're going to start with the cosecant. Which reminder, cosecant is equal to 1 over sine of x. So we're going to repeat this process for the sine function, but then when we fill in the finishing details, we're going to make it into a cosecant function instead of a sine function. So the process is still the same for the most part. So we're going to find a number in front, that's 4. Period is still 2 pi over b, and b here is, if you look, it's attached to the x this time. It's 2 pi over 2. So pi. Interval is the period over 4, so pi over 4. Phase shift, you set the 2x in parentheses equal to 0, and if you solved, you would get 0 for x, so the phase shift is none. Vertical shift, we have nothing at the end there, so we also have none for that. So all we really need to do is graph the interval numbers, and then we'd be good to go. So we have 1 pi over 4. 2 pi over 4 is just pi over 2. 3 pi over 4, and 4 pi over 4 is pi. And then the negatives. All right, no shifts to graph, so we can jump right in and plot our points. So that means our origin is the origin. It did not get shifted. And then we have a sine function technically, so we're going to start at that origin. And then we go up after that, and we're going up 4. And then down to our midline, and then down 4, back up to the midline. Go back to the origin. Instead of going up to, we go up to the right, so down to the left. So down 4, up to the midline, up to the maximum, down to the midline. We'll stop there. Now remember, with cosecant and with secant, we don't draw that curve in. Instead, we use these points to create the cosecant and secant graphs. So the rule is any point on the midline gets an asymptote. Now I usually do this in a, I'm not going to do this in a different color because some of the other problems are going to get a little colorful, and I don't want to make it too difficult for those of you looking at it. So every midline point gets an asymptote. And then all the max points, they get a u that goes up. And then the min points get u's that go down. So you can think of those as like the starting point for their own graphs, for their own separate parabolas. And then you know you've got them graphed the right way when it looks like the maxes and mins are turned away from each other. So this space here is kind of untouched. And that's all to the graph. Similar idea for number 4, except it's the reciprocal of cosine instead of sine. So we know secant is equal to 1 over cosine. So once again, we are going to use the cosine function to get to the secant function. First, we need to find our a, our amplitude. We look in front. There's no number there. That means it's a 1. The period is 2 pi over b. We look for our b, nothing in front of parenthesis, and then the x is by itself, so it is also a 1. Or sorry, 2 pi over b, so it's 2 pi over 1, which is 2 pi. And then the interval is your period over 4. So 2 pi over 4, which is pi over 2. The phase shift, you set the bit in parentheses, equal to 0. So x plus pi over 2 equals 0. And then that gives us x equals negative pi over 2. And then the vertical shift is the bit at the end. It is a plus 3. Let's first graph our interval numbers. So we've got positive pi over 2. 2 pi over 2, which is just pi, 3 pi over 2, and then 4 pi over 2, which is just 2 pi, and then the negatives. And then the shifts. The phase shift is x equals negative pi over 2, so I draw a line through negative pi over 2 on the x-axis. And then the vertical shift is up 3, so now we're going to draw a horizontal line through positive 3 on the y-axis. So where they cross is my new origin. And I am good to start graphing. So this is the opposite of cosine, so I am starting at a maximum. So I have my origin, but I'm really going to start up, and I go up 1. So this is my starting point, up at 4 here, down to the midline, down 1 to make a minimum, back up to the midline, up to a maximum, and then I'm going to finish off these intervals. So I'm going to go 1 more, down to the midline. And then I'm going to go backwards to the left, go down to the midline, down to a minimum, up to the midline, and I'm going to stop there. So once again, because of the shift, I instead graphed 5 to the right and only 3 to the left, but I still ended up with 8 additional points. Now remember, this is secant, not the cosine function. So we will not connect these. Instead, we're going to use them to graph the other pieces of our graph. It's the same as number 3. The midline points get asymptotes. The maximum points get u's that go up. Max goes up. And then mins get u's that go down. So maxes go up, mins go down. And there you have it. All right, next page. Last 2 graphs, tangent and cotangent. I actually quite like these because these just follow a basic template. So as long as you know the template, these are actually very easy to graph. So, tangent function. need to know a few things. First off, the period equals pi over b, so there's a formula change there. It also is pi over b for the cotangent function. The tangent curve starts with middle point on the origin. And again, that depends on where the origin is. And then it has a disco right shape. So for number 5, y equals tangent of 2 times x plus pi plus 2. Oh, another thing, we don't call it the amplitude with a tangent and cotangent, we call it a stretch. So this is still referring to the a value. So we look at the very front, and it is a 1. There's no number there. Period, remember this time is pi over b. The b this time is in front of those parentheses, so it is pi over 2. Interval is the period over 4, so it's pi over 2 over 4. We discussed this on a previous problem, that is pi over 8. Because you keep change flip, oh my goodness. There we go. And you multiply pi over 2 by 1/4, because that's the reciprocal of 4, and that gets you pi over 8. Phase shift is x plus pi equals 0. And then if we solve for x, we get x equals negative pi. And then lastly, we do have a phase shift or vertical shift of plus 2. All right, let's start with the interval numbers. We have 1 pi over 8. 2 pi over 8, which is pi over 4, 3 pi over 8, and then 4 pi over 8, which is pi over 2, which is the period value. So we could stop there and do the negatives. All right. Now, when we go to graph the phase shift, we'll notice a problem. It says x equals negative pi. I don't have that on my graph. In fact, I'm halfway there for the left side because I need to get to negative pi. So I need to go out another 4 notches. So I will need to extend the graph by 2 to get it out there. So we've got negative pi over 2. So that was 4 pi over 8. So this is negative 5 pi over 8. That is negative 6 pi over 8, which is negative 3 pi over 2. 4? 4. Yeah, divide both by 2. And then we've got negative 7 pi over 8, and finally, negative 8 pi over 8, which is negative pi, which we need for the phase shift. So there's the phase shift, and then the vertical shift is plus 2. So horizontal line through 2 on the y-axis. There is my new origin. All right, so tangent starts with the middle point on the origin. So let me kind of back up there. So tangent, you have the origin here. You've got the starting point there. Then you have a point up to the right and down to the left to create that disco right shape. And then you have asymptotes on both sides. And then these are each an interval apart. So that's the basic shape you need to keep in mind. So our starting point is going to be that middle point here. So that's what's going to go on the origin. And then we need to go over to the right, and we're going to go up by our amplitude. Our stretch is 1, so we just go up 1 to get that next point. And then the next thing is actually an asymptote. It would be easy to extend this more to the left, but just due to space and just to show you that you don't have to do that, I'm going to keep this like this. So I'm going to go ahead and connect this. up like that. Now, remember, I'm missing the point to the left and the asymptote. So when I go to repeat this pattern, I haven't graphed the minimum yet, so I'm going to have to do that. If it helps, when you go to graph a new set of tangent, start by graphing the middle point and then graph the right and left side. So that's what I'm going to do. So we've got this asymptote on the left side. I'm going to go 2 intervals over to get my middle point. So there's my next middle point from there. It's in the middle. And then I go 1 to the right and up. And we only go up 1 because that's my stretch. To get my upper point and my lower point is going to be here. And then I will have an asymptote right here. This would have made more sense if I had graphed fully the first one on the left here, but hopefully you're able to follow what I'm doing. So now that I've got a completed one, this is going to be much easier to repeat again. So, again, now this is the ending asymptote for this tangent and the starting asymptote for my next tangent. So again, I like to go 2 to the right first to get the middle point, and then graph the one going up 1 to the right, down 1 to the left, and then my asymptote on the right side there. Next interval gets an asymptote. And then just draw my curve. And then reminder for the tangent and cotangent curves, one full curve, asymptote to asymptote, is a period. So I technically have graphed 2.5 periods here. All right, let's repeat that for the cotangent curve. Few things you need to know about the cotangent curve before we get started. Once again, it also uses that formula. The period is equal to pi over b. And then it starts with an asymptote on the origin. And then this has the opposite shape. This is disco left. All right, let's fill in our information here. Our stretch here, the front number is a 3. The period is pi over b. This time b is nowhere, so it's a 1. So just pi. Interval is still your period over 4. So we have pi over 4. That'll be nice to work with. Phase shift, you set what's inside of those parentheses equal to 0. X plus 2 pi over 3 equals 0. Well, that's just going to be x equals negative 2 pi over 3 if you solve. Vertical shift on the outside there is negative 1, down 1. And then I need to mark my intervals. So we have pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and then 4 pi over 4, which is pi, and then the negatives. And then our shifts. Vertical shift is negative 1. And then the phase shift is negative 2 pi over 3. Now you'll notice that is not on here. So this is going to be a tweener. It will land in between the intervals. And be very careful where you put it. So if you need to, you can always put this in decimal form. Now, obviously, when I make these decimals, I will not be including the pi in my calculations. You can if you want. So we have negative 2/3. That is negative 0.6 repeating. So negative pi over 4, that's negative 0.25. Negative pi over 2, that is negative 0.5. Negative 3 over 4, that's negative 0.75. So as you can tell, negative 0.6 repeating will fit nicely in between the negative 0.5 and the negative 0.75. So that is where I'm going to have my phase shift at. Now, as mentioned before, that is not perfectly in the middle, but for these purposes, it is okay that they're not perfect. So we're going to call that negative 2 pi over 3. And this is going to get a little messy, the overlap here. Okay, so there's my origin. And then we've already discussed that it starts at an asymptote. So if we just draw a little template here of cotangent, its starting value is an asymptote. So, I mean, there's not really anywhere you could put the origin point, if you will. I'll put it in the middle. But it doesn't really matter on the asymptote. And then 2 points over from the asymptote, per usual, is that middle point. And then to make the cotangent curve, to make the disk go left, you go up to the left and down to the right, and then have your second asymptote. And then you just draw your shape, like so. So that's kind of the template we're following here. So on my phase shift line, since this is cotangent, and this is where my starting value is, this gets an asymptote, because that's how I start. So this is both a phase shift and an asymptote. And then I'm going to go 2 over to plot my middle point. Now notice this is landing in between. That's when we call it a tweener. So when I move over, I will not be landing on the intervals. I'll be landing in between them. So have my origin, and I go 1, 2 to the right to make my middle point. And then I'm going to go left and up first. This is a stretch of 3. So I'm going to go left and then up 1, 2, 3 to get my first point. And then I go right, but down 1, 2, 3 to get my second point. And then I go over one more interval, landing in between, and I plot my asymptote. And there is my cotangent curve in all of its glory. Now I just need one more, and since this interval to the right has a little more of the number split out, I'm going to use this one and continue to the right side. So now I'm just going to repeat that pattern. So let's see, I've got my asymptote, and then one interval over, I've got a point at 2. Remember to land in between. Then I go down to my midline point, and the next interval over is at -1, landing in between still. And then go over one more interval, and I go down to -4. And then my last interval over here is my asymptote. Reminder, the nice thing about tangent and cotangent is they're literally a copy-paste version of each other. So once you graph the first one, it's really easy to graph any others that you want to graph from there. There is the entire cotangent graph, 2 periods of it graphed at minimum. All right, I'm going to stop there with that graph and continue on. We are done graphing, but we are still working with equations. So 7 through 9, we are writing equations given the description in words. Number 7, cosine function with amplitude of 4, period of pi, and a phase shift of 2 pi. So first and foremost, let's write the general equation for this function. Y equals plus or minus a, this is cosine, b of x plus or minus the phase shift plus or minus the vertical shift. So let's start this. Y equals, the amplitude is 4, cosine. B, you're never given. You have to come back to it. X, are we given a phase shift? Yes, of 2 pi. Now remember, we have to change the sign when we put it in the parentheses. I will give an explanation on that in a moment. So it's a positive here. It's going to be a negative 2 pi there. No vertical shift, so that will be left blank. One thing I want to come back to, we are not given that this is a reflection, so we know for a fact this is a positive 4 here. So, clarifying on the phase shift. The phase shift is x equals 2 pi. And then we want this equal to 0, so we subtract 2 pi on both sides. So we have x minus 2 pi equals 0. That is what goes in the parentheses. Because remember, how we get the phase shift to begin with on the previous 6 graphs is we took what was in parentheses and we set it equal to 0 and solved. So you have to change the sign essentially when you're putting it back into parentheses. All right, the only thing that is missing is the b. And make sure you really take the time to do this. A lot of you skip this step and you just either leave it out completely or you just hope that b is 1 and that you just happen to be correct. Well, in this case, b actually is not 1. So how to find b? You use the period information. So we know that the period is equal to 2 pi over b. That's the formula. We are given the period is pi. And then we cross multiply. And let's put the pi over 1 for this to be a bit more of an effective explanation. So we're given b pi equals 2 pi. And then remember, you are solving for b. So divide by pi. And then these pi's do cancel out. Pi divided by pi is just 1. B is equal to 2. So that is 2 there. And there you have it. Let's do that 2 more times. Number 8, we have another cosine function. So y equals plus or minus a cosine of b, x plus or minus the phase shift, plus or minus the vertical shift. So we have a cosine function. B we'll come back to in a minute. With a period of 2 over 3 and a phase shift of pi. So let's start with that phase shift. The phase shift of pi is, so that's positive again. So if we have x equals pi, we change that to x minus pi equals 0. So x minus pi is our phase shift. Once again, no vertical shift. It doesn't mention an amplitude, so we are allowed to assume that it is just a positive 1. And then we need to find the b. So once again, b comes from the period equals 2 pi over b. So this time the period is 2/3 equals 2 pi over b. And then we cross multiply. So we get 2 times b, that is 2b equals 3 times 2 is 6 pi. And then don't get ahead of yourselves. Remember, we are solving for b. So we need to divide both sides by 2. And we do get b equals 6 divided by 2 is 3. 3 pi. And there you have it. One more time. Sine function, so I'm going to pause here. Y equals plus or minus a sine of b times x plus or minus the phase shift plus or minus the vertical shift. So y equals, we have sine. So sine function with an amplitude of 19. Period of 7 pi. Phase shift of negative pi over 3. So x equals negative pi over 3. So that means x plus pi over 3 equals 0. So again, we're just changing the sign when we put it in parentheses. And finally, a vertical shift of 1. Let's revisit the a real quick. We are not given a reflection, so we do know this is a positive 19 for sure. And once again, all that's left to find is the b. So once again, we have period equals, so this is still 2 pi over b. The period is 7 pi. Cross multiply. 7 pi b equals 2 pi. And then remember what you're solving for. You're solving for b. So all we have to do is divide 7 pi on both sides. 7 pi's cancel. And then the pi's cancel. So we're left with 2/7. So b is 2/7. Alrighty. Now we just have the trig problems. There are a couple of these where I will show multiple ways. Otherwise, I will just do the easiest and fastest way. All right, number 10. First off, what you don't want to do not multiply, FOIL all of this out. It will cause you so much more headache than it's worth. You can eventually get to an answer, but you have to be a little playful with it, be a little creative with it. Do not recommend. So this is one where I will show you 2 ways. First, I'll show you the longer way that some of you might think to do, and then I'll show you a very fast way. So this is option 1. Once again, I'm not doing this on most of them, just a couple of them. Change the 1 minus cosine squared. So let me write this down first. Change the 1 minus cosine squared to sine squared x. That's a Pythagorean identity. I'm sure most of you would notice that by now. And then you can distribute the sine squared into that. So that gives us sine squared x plus sine squared x cotangent squared x. From here, we know we can break the cotangent squared x down. Cotangent squared is cosine squared over sine squared. And then the sines are going to cancel. So we're left with sine squared x plus cosine squared x, which equals 1. Now, if you haven't already seen where I'm going to go with option 2, you are really going to be kicking yourself that you didn't notice it at first. This one, I think I can actually do this in 2 steps. Oh yeah, I absolutely can. Okay. So let me switch to another color. Option 2. And yes, I can fit it into this space. That should tell you how quick it is. We have 1 minus cosine squared x times 1 plus cotangent squared x. So of course, notice that we have 1 minus cosine squared is sine squared. And then also notice we have another Pythagorean. 1 plus cotangent squared is equal to cosecant squared x. And if you remember, cosecant squared is just 1 over sine squared. And naturally, those will cancel, and you get 1. In my opinion, much quicker, much easier, but the other way isn't bad either. All right, number 11. And I only had one way to show on this one. Cosine of x plus sine of x over tangent x plus 1. Now the top, there's not really much you can do with that, so we're just going to leave this alone for a while. The bottom, though, you can put this in terms of sine and cosine and see where that gets you. As you can see, we don't have any multiplication going on, and we don't have any Pythagoreans. So our only way through is making sure everything is in sine and cosine form. So turn the bottom into sine of x over cosine of x plus 1. And then we are going to change the 1 into cosine over cosine, so we can do some calculations with that. So now instead of 1, it's cosine over cosine. And then I am going to go horizontal here because I'm going to run out of space if I don't. But this is kind of just an in-between step, if you will. I'm just going to write these as one fraction now. Sine of x plus cosine of x over just a solid cosine of x on the bottom. Now that we have a single fraction on the bottom, we can keep, change, flip, and that's exactly what I want to do. So we have cosine of x plus sine of x over 1. So we keep the top the same. Change this from division to multiplication. Yeah, actually I have the space. I'll take an extra step here. My recommendation still is to write this out with the division first before you flip, because I do find a lot of students don't end up flipping. So that is just me. Okay, now I'm going to actually keep, change, flip. So keep this cosine of x plus sine of x over 1 times, so change that from division to multiplication, flip. Cosine of x, yeah, I had just enough space. Over, just for the formatting purposes, I am going to flip this around and go cosine of x plus sine of x. Addition is commutative, so yes, you can flip those around. That is allowed. And as you can see, I have the same thing on top and bottom. We are multiplying here, so this canceling is allowed. And so we are left with just cosine of x as our answer. That's it on number 11. Number 12, I believe I only have one way to show you here. Yes. So, number 12, this one's pretty straightforward. You're going to do it exactly as you would assume you probably would. So, distribute the sign through. We have sine of x cosecant x minus sine of x secant x plus tangent x. And then we have, now I'm going to start changing the forms as I go. Sine of x times cosecant is 1 over sine of x minus sine of x times secant is 1 over cosine of x plus tangent is sine of x over cosine of x. Sine times 1 over sine is just 1 minus, this becomes sine over cosine because we are multiplying, plus sine of x over cosine of x. And then we have a minus sine over cosine plus sine over cosine. Those cancel with each other. And we are left with just 1. Number 13. This one does have 2 options. Yeah, I'm going to show you both. I was debating. Yeah, I think it's good to show you both because I think the first way is how most of you would think to do it, but once you see the second way, you might catch this in the future. Now, I might run out of room this time. We shall see. So, 13, 1 plus cosecant x, I guess write it down, over secant x minus cosine of x. So, most of you might think one of 2 things. The first thing is to try and dwindle this fraction down because there's some stuff to work with here. We got a cosecant and a secant. Maybe you might multiply top and bottom of cosine by secant to see where that could get you. That would be an option. But in my option 1, I'm just going to try to figure out what this will get me so far. So I'm going to change the cosecant and the secant into their reciprocal forms. Take note, these are not Pythagoreans. They do not have squareds. So I cannot replace either of those with Pythagoreans. So this becomes 1 plus 1 over sine of x over 1 over cosine of x minus cosine of x. And then I'm going to turn this 1 to sine over sine so I can combine those two fractions. So then I have sine of x plus 1 over sine of x. And then just to give me a little bit of space, I'm going to go ahead and write this out. So this is sine of x plus 1 over sine divided by 1 over cosine of x minus cosine of x. So right now I'm focused here. Keep change flip. Sine of x plus 1 over sine of x times cosine of x over 1 minus cosine of x. And I'm going to run out of room, so I will grab another piece of paper to finish this off. So, multiplying cosine, we have cosine of x times sine of x plus 1 over sine of x minus cosine of x over 1. Now, I'm writing that second part like that, so as like a signal that I'm going to get a common denominator with the first fraction. So, I'm going to distribute that cosine in, and we write cosine of x sine of x plus cosine of x over sine of x minus, multiply top and bottom by sine of x, and we get cosine of x sine of x over sine of x. Now I'm going to write this as one fraction. I promise you I'm basically done. Cosine of x sine of x plus cosine of x minus cosine of x sine of x all over sine of x. Now I have a positive cosine sign and a negative cosine sign, so those cancel. And we are left with cosine of x over sine of x, which is actually just cotangent x. A lot of work, but I got to the answer. Now let me show you option 2. And hopefully, maybe a lot of you are at a place where you would have picked up on this. But if not, honestly, I find this a little life-changing, I'm not going to lie. I don't know how I want to position my papers yet. Okay, option 2. And this is much faster in comparison. 1 plus cosecant x over secant x minus cosine of x. So right off the bat, if you're trying to take a step back and look at this, you notice that my first fraction has a denominator of secant, and then the right side is just cosine. Now, if we wanted to think of trying to get these together as one fraction, notice that cosine and secant have something in common. They're reciprocals. So off the bat here, I could write this as 1 plus cosecant x over secant minus, change the cosine to 1 over secant, so that we now have the same reciprocal. Now, had you done secant on top and bottom, might have got there, might have not, maybe. So that would have been an option as well. And then, if we combine these fractions, we have 1 plus cosecant x minus 1 over secant. And then the 1 and the minus 1 cancel. We are left with cosecant x over secant x, which is 1 over sine of x over 1 over cosine of x. Keep, change, flip. We have 1 over sine of x times cosine of x over 1. Keep the 1 over sine, change this to division, flip, cosine. Cosine of x over sine of x which is cotangent x. Much faster process. The fractions are a lot easier to deal with, and you still got to the same answer. So this would be my recommendation for this problem. Now, I would have shown that first, but I feel like had I shown you that first, maybe you wouldn't have considered the other option, so I made that option too. All right, number 14. Now we're into verifying problems, so you have to get the same thing on the left side and the right side. I will go ahead and warn you, 14 is not my favorite problem. I really struggled on this one personally, and now once I got to this other way to do it, it's much better, and then the work just becomes tedious more than anything. I believe on the verifying, I'm only going to show you one option per problem. Yeah, so these are going to go much quicker. So, reminder, draw the line and down the middle to remind you that you cannot cross it. So we have 1 plus cosine x over tangent squared and cosine x over secant x minus 1. This would have been better had this been a secant squared x minus 1. We could have made a quick Pythagorean change. But my recommendation from the get-go, when you have two fractions, one on each side, is to get the same denominator. So clearly on this one, you have multiplied these fractions by each other's denominators. So on the left side, I'm going to multiply this by secant x minus 1 over secant x minus 1. And then on the right side, I'm going to multiply that by tangent squared over tangent squared. All right, so on top, back on the left side, for the tops, we're going to FOIL these expressions. So we have secant x plus secant times cosine, which is just 1. And then we're going to distribute the negative 1. So minus 1 times 1, so that's minus 1 minus cosine of x all over my denominator, which is tangent squared x secant x minus 1. And then we have plus 1 minus 1. Those cancel each other out. So now we have secant x minus cosine of x all over tangent squared x secant x minus 1. And then let's change these to 1 over cosine of x minus cosine of x over 1 over our denominator. And by the way, if at any point in time here you get stuck, feel free to go to the right side, work that a little bit, and then try to work on it from there. But since I know where I'm going with this, I'm going to work one side and then the other. All right, so the next obvious, in my opinion, what jumps out at me is to get a common denominator on the top. So we will multiply top and bottom here by cosine of x. So we're going to end up with 1 over cosine of x minus cosine squared of x over cosine of x all over tangent squared x secant x minus 1. And then it's not pretty, but I mean it is the answer that we're going to need. One minus cosine squared over cosine over tangent squared secant x minus 1. All right, I'm going to stop there. Now I'm going to return to the right side and work this real quick. So we multiply, we end up with cosine of x times tangent squared x over our denominator of tangent squared x secant x minus 1. I'm going to break this down. We have cosine of x times tangent squared is sine squared over cosine squared over our denominator. And then the cosine doesn't fully cancel. So this one fully cancels, and then we cancel out the 2. So we're left with sine squared x over just a cosine x over our denominator of tangent squared x secant x minus 1. Now hopefully you can see what the last step is here. I'm going to change this sine squared to 1 minus cosine squared. Likewise, I could have changed this 1 minus cosine squared to sine squared to match what I currently have on the right side. But I ran out of room, so this is what I'm going to do. So my final step is to change this to, and I'll just write it down here, 1 minus cosine squared x over cosine of x over our denominator of tangent squared x times secant x minus 1. And I have the same thing on both sides. And remember, that is the ultimate goal when you're verifying. So once you have done that, you are completely done with the problem. Not my favorite problem. I would call that maybe a medium. It's just a lot of work. I wouldn't say the work is too difficult necessarily, but getting started can be hard for sure. So remember, with fractions, one tactic you can always use is get the same denominator and then use that to get to the same numerator. All right, the last 3 I'm pretty sure are not nearly as bad. Yeah, I'm looking ahead. They're not. Okay, 15. Got to make it red. Cotangent x plus tangent x. Let's work with that. Cotangent we know is cosine of x over sine of x, plus tangent is sine of x over cosine of x. So we have 2 fractions. We're adding. We need a common denominator. So we will multiply the cosine of x times, or the cosine over sine by cosine, top and bottom. And then on the right function, or the right fraction, we're going to multiply sine over cosine by sine, the other denominator. So this gives us cosine times cosine. That's cosine squared x over cosine of x, sine of x, plus we have sine x times sine x. That's sine squared x all over cosine of x, sine of x. Cosine squared plus sine squared, that gives us a solid 1. That's a Pythagorean over cosine of x, sine of x. Here we're kind of at a standstill, so let's go to the right side. Secant x, cosecant x. Well, we know secant is 1 over cosine of x. And we know cosecant is 1 over sine of x. Reminder, we are multiplying, so you just multiply straight across. And so that, if you're not following, will give me my answer. 1 times 1 is 1. Cosine times sine is just cosine sine. Same thing on both sides. We are finished. Two more. 16 looks like it's not a lot of fun, but actually it's not that bad of a problem at all. Gotta make it red. So the goal is to get, when we have fractions, get them down to 1 fraction typically. So we need to get the same denominator. We will multiply each fraction by each other's denominators. So we're going to multiply the 1 over 1 minus sine by 1 plus sine. If I can fit all of this in, we shall see. just going to leave it. It's going to bother me. Okay. It counts. It counts. All right, so we have 1 plus sine times 1. Well, that's 1 plus sine. Plus 1 times 1 minus sine. That's 1 minus sine. All over, and again, the common denominator, so you just write it once. 1 plus sine of x times 1 minus sine of x. Now we have a positive sign and a negative sign. Those will cancel. And then we have 1 plus 1. That is just 2. Now, if you don't recognize the 1 plus sign, 1 minus sign as a pair of difference of squares, you can fully FOIL and get to the answer. If you notice the perfect squares, the difference of squares form, then you would get to the answer quite more quickly. So I'm going to FOIL this out. 1 times 1 is 1. 1 times negative sign. 1 times positive sign. And then sine times negative sign is a minus sine squared x. And then negative sign, positive sign cancel. So we now have 2 over 1 minus sine squared x. Now we are almost there. We haven't touched the right side, so let's take a look at there. So we have 2 secant squared x. Well, we know secant squared is the same thing as 1 over cosine squared. And so that's 2 over cosine squared x. So you can do one of two things. You can either change the 1 minus sine squared to cosine squared as it is Pythagorean, or change the cosine squared to 1 minus sine squared, just so it'll save me having to go down and write another line. I'm just going to do the second one. So this is 2 over 1 minus sine squared x. There you have it. One more, number 17, and this one is not bad at all. What's nice is you're pretty much told kind of what you have to do. Like, you're not given many options, which is a good thing. Sometimes when you're given too many options and your mind's kind of racing, you sometimes will just go down a rabbit hole that gets you nowhere. Here, we know that the right side's 1, so we know we have to get the left side down to just 1. So there's nothing to do with the right side, only the left side. Sine over cosine tangent. We don't have Pythagoreans, no squareds, and we don't have any, we do have some multiplication, but like no reciprocal pairs. So let's work with making sure everything is in sine and cosine. So I will rewrite this as sine of x over cosine of x times, instead of tangent, sine of x over cosine of x. The cosines cancel there immediately. And we are left with sine of x on the top and just sine of x on the bottom. And sine divided by itself, of course, will get us 1. And there you have it. All right, that is all for the study guide. Thank you for bearing with me, especially on that number 14, I believe it was. It took me a minute to do. If you have any additional questions, feel free to email me or come see me in person. Otherwise, I hope you have an awesome day. Bye.